the foundation upon which all streaming APIs are built. All stream APIs are instances of event emitter. Here, why streams are necessary? Here, streams basically provide two major advantages using other data handling methods. Here, two advantages are memory efficiency and time efficiency. In memory efficiency, you don't need to load large amount of data in memory before you are able to process it. If you are not able to process it, you cannot uh, take that data or load that data into that memory. So that is memory efficiency. This is the advantage of using streaming. Then another is time efficiency. It takes less time to start processing data as soon as you have it, rather than waiting till the whole data payload is available to start. So it is time consuming. It will take less time to process that data. Then here you can see the example of streaming. This is a typical example, that is reading files from disk. Here, using that node.js fs module, that is file system module, you can read a file and serve it over http when a new connection is established to your http server. Here this is the example of a stream. Here you can see the example of stream. Here one constant http is equals to require function will import that http module here. Then another constant fs, it will import that fs module, that is file system module. Then another constant here server, for using that methods of that http module. Here equals to constant server equals to http dot create server. Inside we have written one function having parameter request and response. Inside that we have written the method of fs module, that is fs dot read file. Here read file method from fs module. Inside that we are going to read that file name and the data of that file. Here you can see the directory name plus we are going to read that complete file here, data.txt. Okay, then if is there any error, it will return that error, otherwise it will read that file. And at last response dot end data. And at last we are going to listen that server, that is we are going to listen that incoming request at the port 3000. Here read file reads the full contents of the file and invokes the callback function when it's done. Here read file will read the complete file and invoke the callback function. And that response.end here, response.end data, in the callback it will return the file contents to the http client. Using this it will return the contents of that file. If the file is big, the operation will take quite a bit time of, it will take some time if that file is big for reading. Okay, here you can see, so we are writing stream for that. How to write stream? Here constant http equals to require function is for importing module. We are importing http module. Similarly we are going to import that fs module here. Then another constant we are taking as a server, like constant server equals to using create server method of that http module. How to use that? http dot create server, inside the bracket we are going to pass the parameter request and response. And now here you can see inside the bracket we are taking one constant stream equals to fs dot create stream. Fs dot create stream, this is the, this method is from fs module. Stream create read stream, and we are going to read that stream, that is that file name here, directory name plus data.txt. This is a text file we are going to read as a stream. Here stream.pipe in bracket response here. And at last we are going to listen that incoming request here at the port 3000. Then instead of waiting until the file is fully read, we start the streaming using this it to the http client as soon as we have a chunk of data ready to be sent. Here you can see we have written a create read stream function here from the fs module to read that file as a stream. Yeah, there are different types of streams are there. There are 4 classes of streams: readable, writable, duplex, and transform. Here readable streams are a stream you can pipe from but not pipe into. That means you can receive the data but not send data to it. Okay, it means you can read the data but you cannot send the data to it. When you push data into a readable stream, it is buffered until a consumer start to read the data. It is buffer until consumer start to read the data. Whenever consumer start to read the data, it will be readable. Either it will be buffer into that memory. That is readable stream. Okay, then next one is writable. A stream you can pipe into but not pipe from. That means you can send the data but you not receive data from it. Okay, writable means you can send the data to server but you cannot receive from it. That is writable stream. And duplex stream means a stream you can both pipe into and pipe from. That means basically a combination of readable and writable. That is duplex. And transform stream is, it is similar to duplex but output is a transform of its input. It is a transformation of its input. These are the four types of streams. And next one is, this is the last point from the chapter number 5, that is HTTP streaming. Here what is HTTP streaming? It is a push style data transfer technique that allows a web server to continuously send data to a client over a single HTTP connection that remains open indefinitely. It is a simple, or it is a push style data transfer technique that allows a web server to continuously send data to a client. Here in HTTP streaming, a web server continuously sending data to a client over a single HTTP connection that remains open. Technically, this goes against that HTTP convention, but in HTTP streaming, it is an efficient method to transform all kinds of dynamic or otherwise streamable data between the server and client without reinventing HTTP. Whenever we are going to request any data from that web server, after sending the request, it will continuously send the data for a single request in, that is HTTP streaming. Then how that HTTP streaming works? With that HTTP streaming, the server is configured to hold onto a specific request from client. Whenever customer or whenever client is requesting for that server, it will hold onto that specific request from the client and keep the response open so that it can push data through it. When updates pertaining to the request are available at server side, then server sends a response through the request and response channel, and only close the connection when explicitly told to do so. When the client want to end that connection, after that it will end that connection, otherwise it will continue with that pushing the data through it, with that channel, request and response channel. In such a manner, a client can listen for the updates from the server and receive them instantly with none of the overhead associated with HTTP headers and opening and closing of the connection. It also eliminates the need for polling. And how that HTTP streaming works here. Yet to achieve this, to achieve an indefinite response from that server, it must respond to client request by specifying transfer encoding, that is chunk in the header. Transfer encoding chunk in that header. This sets up the persistent connection from server to client and allows the server to send response data in a chunks of new line delimited strings. These chunks of data can be received and processed on the fly by the client. Yet HTTP streaming works like, whenever user sends the request to that server will respond with the request and response channel and sends the data to that client simultaneously. This is how HTTP streaming works here. Where alternatively, the data may be streamed via server sent events, that is SSE method, for which there is a standardized HTML5 API called event source. With that SSE, data is encoded as text event stream in the header. It sends the data in the form of streams, that is piece by piece. It will continuously send the responses to the request of that server or request of that client. This is how HTTP streaming works here. Thank you. In this way, we have finished the chapter number 5. Thank you.